Hi guys, greetings of the day. Myself Vijetha Vardhan, and in this session we are going to have a small discussion about how to draw the isometric projections. And an example problem is like this: a cone base diameter 45 millimeter and height 65 millimeter is placed centrally on the top face of a pentagonal prism, side 45 millimeter and height 25 millimeter. Draw the isometric projection of the combinations. So according to the given condition, we know that a cone has to be located on a pentagonal prism and the respective orthographic projection is going to be obtained like this. Now one can see this pentagon is having the four inclined edges, and according to the isometric projections we know that at the given inclination we cannot draw the lines and the isometric projections. So inclined lines cannot be drawn at the given inclinations. So henceforth, for which we are going to draw a small construction lines. First we are going to draw the parallel lines to the isometric projections. Using these lines, we are going to get the end points. So now one can see that the dimensions of this rectangle as shown in the figure here, and the respective dimensions one can measure, and one can see that these are the respective measurements which are most needed to draw the isometric projections. Now we know that using a line command with a thickness of 0.13 and a continuous line. Now let me start doing the construction. Now the size of this rectangle is 69.25 and the first angle is 30 degree, then followed by 72.81 followed by 150 degree angle, then again 69.25 at an angle of minus 150 degree, and we can connect back to the first point, otherwise we can give 72.81 and minus 30 degree. And after which using the same line command with the thickness of 0.5 millimeter, now let me draw an approximate pentagon, not the exact pentagon. So all these details in the all these things or the constructions of this pentagon we have discussed in detail in the isometric projection basics. So one can visit those basics, then you can learn it much better. Now let me show you. This value is supposed to be 13.91 millimeter, and in the same fashion this value are also supposed to be measured as 13.91 millimeter, and after which the other dimension is 42.8 millimeter. So now let me set that values as 42.8 millimeter on both the sides like this. One second. Yeah, 42.8 millimeter. Now one can see that we have got the required construction of the pentagon. Now the unwanted lines can be deleted which are not required. Now we got the required pentagon. I am going to place it slightly below because we wanted to construct more things, and after which we have to get the isometric projection of the uh, pentagonal prism. Now we have got the only a side, one base. Now we know that using a line command, so we can construct the perpendicular bisectors. By constructing this perpendicular bisectors, one can get the axis position. So the axis of the solid is going to be at the center of the pentagon. So now we know that the height of this axis is 25 millimeter. So we have to draw a 25 millimeter line in the form of a chain line with 0.133, and these construction lines can be eliminated now. Now what we are supposed to do is we have to select this pentagonal edges, then make sure that using a move copy on, then whatever the base is at the bottom, it has to be placed at the top of 25 millimeter like this. Now one can see that we got the top base also. Now with the 0.5 mm and a continuous line, we have to join all the visible longer edges of the pentagonal prisms, and whatever the remaining edges are there, that can be eliminated. And after which one can say that the required construction of the pentagonal prism is completed, and after which we have to construct a cone of base diameter 45 millimeter which is having a height of 65 millimeter. So for which one has to go for a line command with a thickness of 0.5. We have to construct a 45 millimeter square in the isometric projections. So 45 30, 45 150, 45 minus 150 and 45 minus 30, or we can connect back to the first point. Now one can see that the data which we have given may not be a proper one. Yeah. So let me redo this part. That is 45, 30, 45, 150, 45 minus 150, and get back to the first point, or we can give the respective values. Now, all these constructions, once again, we have already discussed in detail about the basics. So now here I am going to just show you how to construct the problems or how to solve the problems directly. Now, these technique is called as 4-arc techniques. That is, the construction of ellipse is going to be done using the 4 different arcs. Now, we have already drawn 2 arcs. Now, I am struggling to draw the third arc. Now, one can see that by multiple times, if you don't get it, then we can go for circle by center point command. Then what I'm going to do, I'm going to draw a circle from here to here. Then using a trim command, so whichever the portion should be trimmed off, it can be removed. And we can go for a command called as mirror. So using the mirror command, one can get that mirror over here like this. Now one can see that we have constructed the required 4 arcs, and afterwards using a line command with a thickness of 0.13 and a chain line. So get the get the center of the ellipse. Then we know that the height of the solid is 65 millimeter. So we have to draw a line for 65 millimeter length. Then change the line style to a continuous line and 0.5 mm thickness. Now we have to draw a tangential line which is connected to the apex or vertex, and again a tangential line to this ellipse. Now the construction of cone is completed in all aspects. Then these construction lines, whichever is there, we can be retained it, or else it can be trimmed. And the invisible lines can be trimmed, or it can be retained as a thin lines. Afterwards, using a command called as move and switch off the move copy, move this cone with respect to the bottom portion of the axis, and it should be positioned on the top portion of the pentagonal prism like this. Then whatever the portion of the pentagonal prism which comes behind this cone can be trimmed, or it can be retained as a thin lines. Now we can say that the isometric view or drawing is completed. To get the isometric projection, this has to be reduced to a isometric scale factor of 0.8164 times. Now one can see that the isometric projections of the given combination is completed in all aspects. Now if you are having any sort of doubts to solve this problem, you can feel free to contact me. And also, if you have liked this video, please press the like button, and also you can subscribe and share the channel to anybody else for the first year engineering students. And also, to get the more video updates on my channel, we can press the bell icon, so you will be getting the latest video updates. Thanks for watching my YouTube channel, guys.